saline is where we are. And go into a little bit of technicality, but I'm just going to give you a brief little overview of saline without going into enough detail where, number one, it's irrelevant. Anything that's irrelevant at this point, it's not even included in any of my lecture series. Do you understand that? Everything that I've been giving you is high yield. So therefore, you don't hear me say high yield, high yield, high yield, because that would be a waste of your time. Everything is high yield. Everything that I'm giving you is a story about something significant in some way, shape, or form is going to be asked. I can guarantee you that. Okay, so coming to saline. It's NaCl. That much we do know. Next, it's isotonic. Now, what's interesting about isotonic is that, now, you look at this and you see 154, and right off the back, you know that does not mean isotonic. Isotonic means approximately how much? Approximately 300. So what does this 154 then refer to? Each electrolyte, Na, cation, chloride, anion, each electrolyte has a millimole per liter unit of 154. But Dr. Raj, if there's two of them and each one's 154, don't you get 308? That is correct. So technically speaking, you're telling me, Dr. Raj, that therefore saline, NaCl, at 308 is slightly hypertonic. Yes, that's exactly what I'm saying. Nothing's ever perfect. Nothing's ever perfect. But this is as close to isotonic saline as you can get. We have, therefore, 0.9%. So it's not 100% that you'll be using for being isotonic for obvious reasons. 308 is a little bit more hypertonic. At 0.9%, that's a calculation that you would use, or should I say 0.9% is the value that you want to know as it being isotonic. Let me give you another example. We've talked about the following. You've injected your patient with isotonic saline slowly over a course of 24-hour period, right? Why slowly? Because if you gave isotonic saline too quickly, what is the diagnosis or what is the disease or dysfunction that you're then going to manifest in that patient? It's called central pontine pons myelinosis. We've discussed that earlier. So slowly. But if you, by chance, give too much NaCl, then you are filling up the entire ECF. You might then be in a state of hypervolemia. What happens to ECF volume? It increases. Is there any other change, yes or no, in any of the total body water compartments? No. The only change was what? ECF volume. No change in osmolarity, either in the ECF or ICF. That we've discussed. If you want a little bit more detail in terms of the liters and the units and such, there it is. At this point, you're good with knowing 0.9%. Okay, now, this discussion is important. I need you to understand the terminology of half normal saline. So if one half is normal saline, what is saline? NaCl, okay? Saline is NaCl. So if half of your solution is NaCl, saline, what's the other half? Water. What's the difference in terms of distribution? Before we move on, let us now predict what you can expect or predict as far as distribution of these fluids. If it is going to be half normal saline, tell me about that saline. That saline will only be distributed in which compartment? I'm sorry, what did you say? Only in the ECF. Good. So the saline component of this is only going to be distributed in the ECF. Tell me what are the fractions that you want to know? 3/4, 1/4, 3/4, 1/4. 3/4 interstitium, 1/4 plasma. Stop there. What about the other half? The other half was pure water. Okay. That pure water, tell me about its distribution. Throughout the total body water. Throughout. What does that mean? That means 1/3 of that water will go into where? Good. It'll go into ECF. 2/3 of it will go into the ICF. And then from there, that 1/3, you'll divide into 3/4 and 1/4. Is this too much detail? No. Is this expected of you as being a first-year medical school student or a resident? Yeah. Ultimately, how often would you use IV fluids? All the time. So it's imperative that you at least know a few differences here and what it truly means to be normal saline versus half normal saline. And if it's half normal, what's half of 9? There you go. Take a look. 0.45. Why did I say 9? Because normal is what? 0.9. Are things coming together? Before we move on, one last thing. If each electrolyte had a millimole of 154, and you're taking half of it, then this then brings us to 77. 77 is designated for each electrolyte. Thus, when you add them both, how much do you get? 154. Is 154 normal plasma osmolarity? Yes or no? Not at all. What's normal plasma osmolarity? Approximately 300. So what kind of solution is half normal saline? It's hypotonic fluid, is it not? Conceptually. So things that you want to keep in mind. That was a little bit of math there, a little bit of calculation. Let's put things together. And as we do so, I'm going to walk you through the concepts. That is the most important thing. You as a clinician, you as a doctor are always striving for concepts. Once you get the concepts down, then you can put in the math as you wish. So conceptually, one can think of the following. We have examples here. Let's do a half normal saline. What does that mean to you? Half water, half saline. The half of the water, which is our first component here, what does it do? Look, equally distributed through TBW, what's highlighted here in red. Now, total body water includes 2/3 of ICF, 1/3 of your ECF. What about the other half? The other half is saline. Where are you only going to distribute? Can you predict this? Good. There you have it. ECF. 3/4 interstitium, 1/4 plasma. Did you ever think that something that you learned way back in physio, in terms of basic concepts of total body water, would become so incredibly crucial for you to understand the pathology? We have spent quite a bit of time with total body water compartments with all kinds of diseases, and now we're finishing it up. We're doing, we're adding the icing with IV fluids. Now, once you've understood half, let's do a quarter. What's this mean? The quarter is referring to the quarter saline. That would mean only 1/4 of this is saline. And what about that 1/4? Now we can do a little bit of math here, can't we? A liter of quarter normal saline. What's a liter? 1,000 milliliters. Clear. Of the 1,000 milliliters, and I'm then giving your patient quarter normal saline, how can you think of this? Well, you divide this into, of the saline, you then take your free water, which is going to be 750, because only a quarter of this is saline. 750 is water. You tell me about that water and distribution. You got this down? What about that water? Throughout total body water. ECF, ICF, ECF, ICF, all throughout it. Then what's that quarter mean? 250 would be your saline. And tell me about that 250. Good. It'll be distributed between your ECF only. ECF only. This is what kind of fluid? Once again, hypotonic. So now we have normal saline, half normal saline, quarter normal saline. This is the first time we've added a little bit of math with 1 liter of quarter normal. Let's continue.